Alright, so today we're solving systems of equations by graphing, and we are going to investigate graphing systems of equations using our tools of graphing as well as our graphing calculators. So let's just review what we did yesterday. We have equations here, and equation number 1 is in standard form. So what we're going to do is plot our x and y intercepts from standard form, and we are going to look at our equation. So number 1, our x-intercept when y is 0 is at 2. So when y is 0, x is 2. And then my slope for that first equation would be subtracting over x and dividing by 3. So equation number 1 would be y equals negative x thirds shift plus 2 thirds. So again, we don't really want to graph a y-intercept of 2 thirds, so that's why we started with the x-intercept. And then we're going to apply our slope, which is down 1 and over 3. Connecting our lines, we have our first equation. And then we're going to do the same thing for the second equation. What's nicer about equation number 2 is that the x and y intercepts in this case are rather nice. So when y is 0, we have 3x equals negative 6. Divide by 3, we get x equals negative 2. So my x-intercept is negative 2. And then when x is 0, you get 3y equals negative 6, so you get y equals negative 2. So my y-intercept is also negative 2, which means my slope is negative 1, which means my slopes are different, because the slope of the first line is negative 1/3, the slope of this line is negative 1, and if I extend my graphs, I can see that their point of intersection occurs right here at the point negative 1, 2, 3, 4, 2. So what that means is the solution to this system of equations is negative 4, 2. Okay, number 2. Once again, we're going to solve for y. So over here, we get y equals negative 2x plus 5. So we'll graph our y-intercept. And apply our slopes. So we're going to go down 2, right 1, down 2, right 1, down 2, right 1, and continue that pattern. Okay, and then let's also look at the second equation. So we get y equals x by adding x over plus 2. So we can just see, even comparing the two equations side by side, that the slopes are different, the y-intercepts are different. So when the slopes are different and the y-intercepts are different, then I know right away that this is an independent system of intersecting lines that will have one solution. So that's why that vocabulary was so important to understand at the beginning of the section, because just knowing about your slopes, your y-intercepts, you know what answer type you're looking for. So I know I'm looking for an independent system of intersecting lines that will have one solution. And then in this case, that one solution is so upon graphing our green line, we are going to be able to see that the y-intercept is positive 2. My slope is positive 1. And our two lines do in fact intersect. And they intersect right here at this point, 1, 3. So that one solution is, in this case, 1, 3. We can also use linear regression that we talked about in section 2.5 in order to compare linear models. So it said the table shows the number of shoes a pair of employees sold at a shoe store. Using the linear regression feature of a graphing calculator, find linear models for each of the employees' sales. So what we can do is look at each of those models. So go ahead and take out your graphing calculators. So what we're going to do is use the table of values in order to find our linear regression for each of the equations. So you're going to turn on those graphing calculators. You're going to go to Stat. You're going to go to Edit for your data. If you have data in there, you can either type on top of it, or you can arrow up to the list, hit Clear, and Enter. Arrow over to the list, hit Clear, and Enter. And then what we're going to do is in week 1, we're going to go down 1, 2, 3, 4. And then in L2, we'll start with Ed. So we'll type in 50, 55, 63, 67. And then what we're going to do is we're going to use linear regression. So you're going to go back to Stat. You're going to arrow to Calc. And then you're going to go down to linear regression and hit Enter. If you have the graphing calculators in my classroom, you're just going to hit Enter one more time. If you have a newer calculator, you want to make sure it has L1, then L2, and then you're going to go down to Calculate, and we're going to get our linear equations. And our value of 0.99 tells me that my data is a strong positive, and then the A value is my slope. So Ed's equation is y equals 5.9x plus 44, where 44 represents the y-intercept. And then we're going to do this again for Joe. So you're going to go to Stat, Edit, and then in L2, all I'm going to do is type on top of Ed's data with Joe's data. So 40, 47, 56, and 62. Go back to Stat, go to Calculate, go back to Linear Regression, L1, L2, go to Calculate, and I see that Joe has a linear equation of y equals 7.5x plus 32.5. So taking what we know about linear regression and what we know about their equations, my slopes are different. Therefore, these are independent, intersecting with one solution. So the question we get asked is to use the graph of the models to predict the day in which they could sell the same number of the pairs of shoes. So what we're going to do is kind of what we did in the past. We're going to go to y equals. You're going to clear out any data you have in there. And now we're going to type in Ed and Joe's equations. So 5.9x plus 44, 7.5x plus 32.5. So again, you want to make sure when you do this that your plots are off and then your equal signs need to be on because that tells me it's graphing my equal signs. We're going to think about our data for a minute here. So you're going to go to Window. A window of -10 to 10 isn't really good for this set of data because our data in terms of weeks, you're not going to have negative weeks. So we're going to go to week 0. And maybe we'll go out just a little further than 10. Maybe let's go to 15. Better to be out a little too far than stay in too close. And then for the Y-men, they're not going to have a negative number of shoes. Its y-intercept is 32 and Ed's y-intercept is 44. So I'm going to start my y values at 25, just a little bit below those y-intercepts, because we know the graphs aren't going to go below that anyways. And then what we're going to do is take our Y max. At week 4, it's 67 and 62. So I'm going to take my Y max all the way out to 90. And to make my graph quicker, I'm going to make my Y scale 5. And then we're going to go to graph. So the first line graphed is Ed. The second line graphed is Joe. So we can definitely tell they intersect, but it is really hard to tell where they intersect. So let's go back to that window. And again, that's the point of the window, is to adjust to what you need. So I might go to 125 on my Y max because I could tell that I was losing it off the screen. And now, by making my 125 higher, I can see that the two graph, one goes here and one goes there. And they intersect somewhere here in the middle. So you have like a plus sign if you just hit the arrows on your keyboard. But that doesn't really help us because I'm guessing with that. So what we're going to do is we're going to use a feature on our graphing calculator. You're going to go to Second, Trace. And you're going to go down to feature number 5, intersect. And what that's going to do is now put that plus sign on the first equation. So right now we're moving along Ed. So all the x values you're seeing on the bottom are Ed's x values. So we're just going to move Ed's guess to like the middle near where they intersect and hit enter. We're going to do it again. Now we're on Joe's line. So we're going to move Joe towards where they intersect. The third one, you always just guess. It really doesn't matter where you guess, you just hit enter. And the point of intersection is 7.9. So it says use the graphs of the models to predict the week in which they could sell the same number of pairs of shoes. So the week they'll sell the same number of shoes is week 7 with 86 or 87 pairs of shoes because you can't sell 86.4. Let's investigate one more set of data. So what we're going to do is plug in the years and the Olympic times. So go back to stat, go back to edit. We're going to go to L1. We're going to type in our years. So upon looking at this, we are going